Good morning. This is Industrial Electronics by Professor Reddy. We are still in Unit 4, that is the 5th lecture. Here I am going to discuss some of the questions given in the end examinations and their answers or solutions. Question number 1. Explain the principle of resistance heating. As the diagram indicates, electric resistance welding. Resistance heating is a welding process where metal pieces are permanently joined by heating them with electric current, melting the metal at the joint. Okay, so as you can see the diagram, the power supply goes through welding transformer. It is given to welding electrodes. Okay, welding electrode 1, electrode 2, and between electrodes there are metal pieces, work pieces are given. That is actually electric resistance welding. It is done only due to resistance heating. Okay. So I repeat again, resistance heating is a welding process where metal pieces are permanently joined by heating them with electric current, melting the metal at the joint. The welding process is based on resistance heating by current flow through two metal pieces. The welding process is based on resistance heating by current flow through two metal pieces. So the welding thermal energy W produced is given by W is equal to integral 0 to TW I square R dt, where R is resistance between metal pieces to be welded in ohms. R is resistance, and TW is time during which welding current flows in seconds. I, instantaneous current in amperes. So the heat produced due to resistance depends. Heat is directly proportional to thermal energy. It depends on three factors. One is resistance, another is current, another is TW. So it depends mostly on current, I square, because it directly I square. And on resistance, I square R, it gives power over a period of time, TW. TW is time, that is welding time, how much time. So more time, more heat is produced. More resistance, more heat is produced. More current, more heat is produced. So that's how the electric resistance welding is called nothing but is done through resistance heating. Done through resistance heating. That's why it depends on resistance and current. Mainly the current. The power supply will produce current of the when the welding transformer secondary current is very high. Secondary current goes from 100 amperes to 1000 amperes. So welding current is high. So it is actually current square I square that determines what is the thermal energy or heat. Okay, it depends on R, that is the resistance, which is resistance that is produced between metal sheets. Okay, so I square R that gives actually power over a period of time, that is welding time, TW. That produces what you call the thermal energy or heat. Okay, then two metal pieces are heated to the required temperature and they are welded. Okay, the main advantage of the resistance welding is it does not require any other external material for welding them. Okay, metal pieces are automatically welded because of high temperature. Okay, that's how it works. Next, Another question asked in the university examination is illustrate the process of energy storage welding. What is energy storage welding? So here is a circuit of energy storage welding process. It consists of three-phase supply, three-phase ignition rectifier, and there are three switches S, S1, S2. Okay. R1, S is the main switch, S1, S2, and R1, R2. There is a welding transformer, primary current IP, and secondary current IS, and welding electrodes, and of course welding sheets. That is what is the circuit diagram of energy storage welding process. So here the current waveform T is produces how IP goes to peak, then IS starts, secondary current starts. Okay, due to energy storage. Okay, so process. Please note down the circuit diagram. Already it is there, I think, in the notes. Okay, so he has asked to illustrate the process of energy storage welding. Energy storage welding. So here actually the primary is fed by three-phase ignition rectifier. Then the primary of the transformer, primary current of this transformer, it increases exponentially and reaches some maximum or peak value. Then suddenly all these switches are opened. Okay, initial switches are closed. All these switches S, S1, S2 are opened. Then the energy developed in the primary suddenly goes to the secondary. That is what we call energy storage. It goes to secondary and produces a pulse-like current, IS, secondary current, the form of pulse. So that is useful for welding the metal pieces. Okay. So the process is by closing initially S1, S2, three-phase ignition rectifier supplies DC current IP to primary welding transformer. Okay. The current increases exponentially. The IP increases exponentially with a large time constant due to inductance of welding transformer L in the primary. The energy stored in the core is given by W is equal to half L IP square. The energy stored is W is equal to half L IP square. Now, when IP reaches maximum value, then S, S1, S2 are opened, resulting quick decay of magnetic flux, which induces very high secondary current, IS, as shown in the diagram. It produces a pulse, secondary current in the form of pulse. Okay? The surge of IS pulse flows through welding electrodes, performing the welding operation. It produces narrow, high secondary current, IS pulse. This pulse is ideally suited for welding some materials. This is called energy storage welding, because here energy is stored in the primary of the welding transformer, and suddenly the supply is cut off and this energy is induced into secondary as a pulse, and now thus pulse will be used for welding the metal pieces. Okay, this is what we call energy storage welding, the process of energy storage welding. It is useful for a number of materials. Okay, that is what is energy storage welding. Okay. Then we have question number 3. State the advantages, disadvantages and application of electric resistance welding. State the advantages, disadvantages and applications of electric resistance welding. Of course, as we have discussed, electric resistance welding 5 types. 1 is spot welding, 2 is butt welding, 3 is seam welding, 4 is projection welding, 5 is flash welding. There are 5 types of welding. Okay. Now we'll discuss what are the advantages. Resistance welding is used in welding and fabricating all types of metal sheets. Number 1, in welding and fabricating all types of metal sheets. Number 2, in fabrication of boxes, cores and cases. Number 3, for welding pipes, tubes, rods, etc. Number 4, for making leak-proof tanks. Number 5, for welding nuts to plates. Number 6, we get better finished products. So there are some of the advantages of this resistance, electric resistance welding. We have, of course, some disadvantages also. Resistance welding has disadvantages like more heat is produced. Okay, so cooling system is to be incorporated. More heat is produced. Otherwise, the electrodes gets heated up and they will be welded to the metal pieces. Sometimes welding electrodes may be welded to the metal sheets to be welded. Okay. So instead of welding metal sheets, the electrode itself will be welded to the metal sheets. So it is very difficult again to remove the electrodes. Then third point is high pressure is to be applied. Okay, between electrodes. That is a disadvantage. Then the applications. We have of course plenty of applications. They are used of course for welding all types of metal sheets, fabrication of boxes, cases, etc. For making edge-to-edge joints and for assembling parts of equipment and for production works and also for fabricating or for heating large number of metal sheets, welding large number of metal sheets, okay, in the industry. This electric resistance welding is used because it is very fast. This can be done on a large number of metal sheets or metal boxes or whatever may be finished products, okay, for making, for pipes, for connecting welding pipes, welding tubes, welding rods, etc. For all things, very fast. Okay, this process is very fast. So these are some of the advantages, disadvantages, and applications. Okay, this is the most commonly used asked question. Okay, what are the advantages, disadvantages, and applications of electric resistance welding? Then we have what we call fourth question. Fourth question is explain the principle of what we call induction heating and give its merits. Explain the principle of induction heating and give its merits. Already, I think we have discussed about induction heating elaborately. Those who are not seen, you can note down how induction heating works. It has a conductor placed in a coil L of inductance L, and the coil high frequency AC source is about 500 Hz to 500 kHz frequency is applied. The high frequency AC source that is given to the coil. Okay, the conductor to be heated is placed in the coil. Okay, that is what we call the induction coil or induction heating. Please note down the diagram. So, what is induction heating? If a conductor is placed in a coil and high frequency AC voltage is applied to coil, if a conductor is placed in a coil and high frequency HF AC voltage is applied to coil, it produces time changing magnetic flux and EMF is induced in it. This induced EMF produces eddy current. I think already we have discussed. It produces time changing magnetic flux. The flux induces an EMF. This induced EMF produces what we call eddy current. This eddy current is used for heating metal pieces, conductors. This is called induction heating. So I'll repeat again. If a conductor is placed in a coil and HF, high frequency AC voltage is applied to coil, it produces time changing magnetic flux and EMF is induced in it. This induced EMF produces eddy current. This eddy current is used for heating metal pieces, that is conductors. This is called induction heating. Okay? What are the merits of induction heating? Induction heating is used in surface hardening of steel mainly. Induction heating is used in surface hardening of steel. That is number one. Number two, it produces, of course, very high heating rates. Up to 750 degrees centigrade can be obtained. Very high heating rates can be obtained. Okay. Number three, the portion of the surface to be heated can be accurately controlled. That is one of the main advantage merit is we can accurately control the depth of heating, the portion of surface on the surface from the surface. Okay, for surface heating, how much depth we have to heat, the portion of the surface to be heated can be accurately controlled. That is, we can calculate that and we can control based on what is the time of heating. We can accurately control the heating process. And there are other advantages also. It is a very simple process, even non-technical. Okay, people can operate this induction furnace. So there are some of the other advantages that are already given in the notes. So this is a usually asked question. Explain the principle of induction heating and give its merits. Induction heating and give its merits. It's a very, very simple question to be answered. Okay, with this simple diagram of induction heating and the definition of induction heating. Okay, already discussed here, and right merits. So I think that will fulfill the what is the required answer. Okay, if you want some more merits, some more advantages, it is already given in the notes. So you can go through the notes. It is already supplied. Okay, you can go through that. We have a number of advantages, characteristic features of induction heating, number of advantages of induction heaters. In fact, induction heating is a very simple heating and which can be operated even unskilled labor. Okay, unskilled labor can be employed to operate induction heater, and we can heat large number of conductors. Okay, using this method. Okay. There are a lot of applications. Already I have given applications of induction heating, the notes also. Okay. So, but the very simple question is the principle of induction heating and its merits. This is a simple question asked in the university examination. Please go through it, and it is very easy to answer, very easy to study also, to make things very simplified. I am explaining again. Then another typical question asked in the university: explain in detail about the high frequency power source of induction heating. Explain in detail about the high frequency power source of induction heating. Here there is a typical induction heating circuit using voltage fed inverter. Here AC power supply is to be given to converter. We get DC, we have inductor and SCR and 4 SCRs connected in bridge form, and in the load circuit there is an inductor L-, induction coil, the capacitor C is connected in parallel. That is the circuit diagram of high frequency power source of induction heating. This circuit employs voltage fed inverter. This circuit employs voltage fed inverter. Here IH induction heater coil operates like a short-circuited transformer with a low power factor. Here IH coil operates like a short-circuited transformer with low power factor. Load coil L- is used to compensate for power factor. DC series inductor and DC parallel capacitor keeps voltage constant. DC series inductor and DC parallel capacitor keeps voltage constant. The load current passes through the coil and produces induced EMF, and the eddy current which produces induction heating. This is of course very simple but very effective method of producing induction heating. Okay, it is also very frequently asked to explain in detail about the high frequency power source of induction heating. This is a commonly employed heating arrangement in the industry. Okay, the typical induction heating circuit or system using voltage fed inverter. Okay, they will be putting what is the conductor to be heated in that induction coil. There is a provision for putting conductors in that induction coil, and a large number of conductors can be heated. So mostly for the surface hardening of steel rods, it is used in a large scale. Okay, so this circuit produces very good heating arrangement for under very quick arrangement because of this inverter, voltage fed inverter. Because of that, it produces a lot of heat, and the conductor can be heated very quickly, and a large number of such conductors can be heated, okay, on large scale. So hundreds and thousands of conductors can be heated by induction heating. So that is in industry. So this is usually a user circuit in industry. So all of you must study this circuit and go through its operation, how it works, because it is usually asked in most of the end examinations, induction heating. Similarly, of course, dielectric heating also is, of course, there is not a principle of dielectric heating. Is also already you know it. Okay, is no need to discuss. I have already given detailed notes for dielectric heating also yesterday, and please go through that notes, and whatever question, most of the questions asked on dielectric heating are very simple. Just to explain the principle of dielectric heating, or applications of dielectric heating, or what are the differences, of course, between induction heating and dielectric heating. That is also given in the notes in the last class. very clearly. Okay. Anyway, this completes Unit 4. So from tomorrow, we'll discuss in detail Unit 5. Unit 5 already I sent the notes, scanned my notes and already sent my notes. Please go through that and I will give explanation, okay, about the Unit 5 topics. Thank you very much. Okay, we'll close Unit 4 now.